Okay, so we're going to look at Chapter 3, Section 1, Problem 41, with this function, f of x equals 5 minus 12x minus 4x squared. And we're going to want to convert it into the standard parabola format of f of x equals a times the quantity x minus h squared plus k. And this tells us where our vertex is. So the first thing I'll do, I'll switch colors here, I'll go to a purplish, I think, is I rewrite my function in descending powers. And so I've written the square term out front, the x term in the middle, and the constant at the end. Now, we're going to want to complete the square, but we're going to do it where we don't really have a left-hand side. I don't have a side where I can add things towards, because this function can take any value. So what I'm going to need to do is I'm going to work in it in sections. So I'm only going to worry about the terms that have x in it. And I notice they both have a negative 4. So I'm going to pull the negative 4 out. That's going to leave me with x squared plus 3x. And I want to put the plus 5 over here, give myself some room. So the portion I want to complete the square on is in the middle here. It's the part that is in the parentheses. This I want to force to be a perfect square, so I can write it in this term of x minus h. So when I complete the square, I take the term to the first power and I half it. So half of 3 is 3 halves. And I square that answer. So let me just put a note over here. I'll put it off to the side over here. Where do I want? I want some little side. I'll scroll up a bit here. And I'll say, hey, 3 divided by 2 squared. That's going to be 9/4. And that's what I want to add to my function. I want to add, though, well, I can't add something to the function without changing its values. The only thing I can add to it is 0. And so I'm going to add my 0 in this form. It's going to be 9/4 minus 9/4. I'll keep the plus 5 out here. All right. This is 0. I haven't changed the value of anything in there, but I've made this part a perfect square. And so this bit here is a perfect square. And it's a perfect square such that its ending term is this 3 halves. But I need to get this negative 9/4 out of the parenthesis. Well, notice everything in the parentheses would be multiplied by a negative 4. So if I want this to come out, this has got to go through this gatekeeper of negative 4. And negative 9/4 times negative 4 is positive 9. So I get my negative 4 hanging out here. I get my 3x plus 9/4. And then this comes out, and I have positive 9 plus 5. Well, I'll combine these out here to give me a 14. Keep the negative 4 here. We forced this to be a perfect square. We forced it to be a perfect square. If I write this correctly as a 4th down there, sorry about that. We forced this to be a perfect square where it was 3 halves. Right? This term here that we squared to find what we were adding is what makes this a perfect square. And now we have this in our a plus hk. We know that it's negative, so it's going to be a maximum like this. We also know that our vertex is going to be at negative 3 halves, comma 14. That's the point of the vertex, because there is our h and our k.